Have you ever had trouble getting to school on time? Well, our friend Asif seems to be having the same problem. Let's see if we can help him out. Asif rides his bike from his house to school every day. Here is a simple map of the area. Currently, Asif cycles from his house along Iqbal Road for 6 kilometers and then 8 kilometers up Jinnah Road to get to school. He thinks this is the shortest route he can take, but he still gets late every day. That's when Sarah came to the rescue.
Asif, you would get to school on time if you used Share Faisal. It's a much shorter route from your house to your school.
Asif was confused.
Are you sure, Sarah?
Absolutely.
Well, how did you figure out that the distance is shortest when we take Share Faisal?
It's really simple, Asif. I use the Pythagoras Theorem.
That's really smart of Sarah. Let's see how she applied the Pythagoras Theorem to figure out which route is shorter. Notice that the roads leading to Asif's school make a perfect right-angle triangle, with the right angle between Iqbal and Jinnah Road. Comparing this path to a right-angle triangle, Iqbal Road would be the base, Jinnah Road would be the perpendicular, and Share Faisal would be the hypotenuse. How can we find out the length of Share Faisal? The Pythagoras theorem states that in a right-angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Applying the Pythagoras theorem to Asif's route, the square of the length of Share Faisal would be equal to the sum of the squares of the lengths of Iqbal Road and Jinnah Road. This means that the square of the distance of Share Faisal is equal to 6 kilometers squared plus 8 kilometers squared. This is equal to 36 square kilometers plus 64 square kilometers, which is equal to 100 square kilometers. To find the length of Share Faisal, we take the square root of both sides of this equation. The square root of 100 is 10. Hence, the length of Share Faisal is 10 kilometers. We know now that Share Faisal is 10 kilometers long. Compare this to Asif's original route. Asif's current route is 6 plus 8 kilometers long. That makes a total of 14 kilometers. Share Faisal is clearly the better choice. The path is 4 kilometers shorter than Asif's current route.
Oh, wow, Sarah. It seems you were right. I will be using this route to get to school now, thanks to the Pythagoras Theorem.
Let's get some more practice applying the Pythagoras Theorem. Time for an exercise. A ladder is put against a wall at a height of 12 meters. The length of the ladder is 15 meters. Can you find the distance between the foot of the ladder and the wall? Compare the image of the ladder leaning against the wall to a right-angle triangle. In this case, the ladder is the hypotenuse. The distance between the foot of the wall and the top of the ladder is the perpendicular, and the distance between the foot of the ladder and the wall is the base of this right-angle triangle. Let's call this triangle ABC. Applying the Pythagoras theorem to the triangle, AB squared is equal to AC squared plus BC squared. Replacing these with their numerical values, 15 squared is equal to 12 squared plus BC squared. Simplify this further and we get 225 is equal to 144 plus BC squared. Subtract 144 from both sides to get the square of BC. Flipping this equation, we can see that the square of BC is equal to 81. Taking the square root of both sides, we find that the length of BC is equal to 9 meters. We just used the Pythagoras theorem to find the length of the base of a right-angle triangle. Amazing, isn't it? It's time to summarize. The Pythagoras theorem can be used to find the length of an unknown side in a right-angled triangle if we are given the lengths of the other two sides. The Pythagoras theorem can be applied to find unknown distances in real-life situations where right-angled triangles are formed. Can you find any right-angled triangles around you?